Hello, good morning, my dear students. Myself, Debi Prasad sir. Today we'll study about the problems based on empirical and molecular formula. Let us come to the first example. A compound of carbon, hydrogen, and oxygen is found to contain 40% of carbon, 6.5% of hydrogen, and 53.5% of oxygen. Then calculate its empirical formula. If its vapor density is 30, then calculate the molecular formula. Given that the atomic weight of carbon is 12, hydrogen is 1, and that of oxygen is 16. Now, my dear students, you have to make 5 coulombs consisting of the element, percentage composition, atomic weight, relative number of atoms, then the simplest ratio of whole numbers. Now, in this question, it's given that carbon 40%, its atomic weight 12, and a relative number of atoms, it is the percentage composition divided by its atomic weight. That is 40 by 12 equal to 3.33. Next, hydrogen 6.7% and atomic weight is 1 and the relative number of atoms is 6.7 divided by 1, that is equal to 6.7. Now, oxygen 53.3% and the atomic weight is 16. Then the relative number of atoms is 53.3 divided by 16, that's equal to 3.33. Now coming to the simplest ratio of the whole numbers, it is the value obtained in the coulomb number 4 divided by the least value of this coulomb, that is 3.33. Therefore, every value of coulomb number 4 is divided by the least number, that is 3.33. Therefore, we get in the first case, that is for carbon, 3.33 divided by 3.33 equal to 1, and for hydrogen it is 6.7 divided by 3.33 equal to 2, and for oxygen it is 3.33 divided by 3.33 equal to 1. Therefore, the empirical formula of the compound is CH2O. Now, the molecular weight is equal to 2 times of vapor density is equal to 2 into 30, that is equal to 60. Now, the empirical formula weight of the compound is 12 plus 2 atoms of hydrogen is 2 plus 1 atom of oxygen, that is 16, is equal to 30. Now, N is equal to molecular weight divided by empirical formula weight, that is equal to 60 divided by 30 is equal to 2. Now, the molecular formula is equal to N times of the empirical formula, that is equal to 2 times of CH2O. It comes to C2H4O2. Now, the molecular formula of the compound is C2H4O2. Now, my dear students, proceeding to the example number 2, it is given that a compound has sodium 18.6%, sulfur 25.8%, hydrogen 4.03%, and oxygen 51.58%. Asked to calculate the molecular formula of the salt, and assuming that all the hydrogen in the compound is in combination with the oxygen as water of crystallization, the molecular weight of the compound is given 248. The atomic weight of sodium is 23, that of sulfur is 32, and oxygen is 16. Now, coming to the same procedure, that is, first of all, you have to make 5 coulombs, that is element, percentage composition, atomic weight, relative number of atoms, and the simplest ratio of whole numbers. Now, in the element coulomb, we have sodium, sulfur, hydrogen, oxygen. The percentage of sodium 18.6, that of sulfur 25.8, hydrogen 4.03, oxygen 51.58. Atomic weight of sodium 23, that of sulfur 32, hydrogen is 1, oxygen is 16. Now coming to the relative number of atoms, 18.6 divided by 23 equal to 0.80. For sulfur it is 25.8 by 32, that's equal to 0.80. For hydrogen it is 4.03 divided by 1, that's equal to 4.03, and for it is oxygen 51.58 divided by 16 is equal to 3.22. Now in this column the least value is 0.80. Therefore, in order to get the values under the column simple ratio of whole numbers, all the values of column number 4 is divided by the least value. Therefore, for sodium it is 0.8 by 0.8 equal to 1. For sulfur it is 0.8 by 0.8 equal to 1. For hydrogen it is 4.03 divided by 0.8, it is 5. And finally for oxygen it is 3.22 divided by 0.8 equal to 4. Now the empirical formula of the compound is NaSH5O4 and the empirical formula weight is 23 plus 32 plus 5 plus 64. It is 124. Now the molecular weight of the compound is given in the question 248. Then N is equal to molecular weight by empirical formula weight, that is 248 divided by 124, that is equal to 2. Now the molecular formula is equal to N times the empirical formula, that's equal to 2 times of NaSH5O4, that's equal to Na2S2H10O8. In the question given that all the hydrogen is present as the water of crystallization. Since in the empirical formula the number of hydrogen atoms is 10, then it implies that the compound contains 5 water of crystallization. Therefore, the molecular formula of the compound is Na2S2O3 My dear students, I hope that you understood this part of the addition. Rest part you will get in my next video.